have a self-sustaining settlement on the surface of Mars?
I think it can be done in 20 years.
But it would take 20 years. So we're not, in 29, we're not there. What are we missing?
Well,
what are the big technologies we don't have?
A few people running around the surface in a hostile environment is not going to make it self-sustaining. Right. So you're going to need on the order of 1 million people, maybe 1 million tons of cargo.
So, but you think we could have 1 million people on Mars in 20 years?
Yes.
And what's the technology we're missing right now?
Elon Musk wants a Mars colony with 1 million people by 2050. But several technological breakthroughs will be necessary for so many people to survive on the red planet. Let's dive in. Nuclear thermal propulsion, NTP. Starship journeys take around 6 to 7 months from Earth to Mars and are only possible every 26 months. In order to have much more flexibility in the flight plan and to be able to travel to Mars much faster, nuclear propulsion is necessary. Nuclear thermal propulsion, NTP, would be 2 to 5 times more efficient than traditional chemical propulsion. How do they work? A nuclear reactor quickly heats super-cold hydrogen propellant to a very high temperature in a fraction of a second, creating a high-pressure gas. That gas is then funneled through the engine nozzle, creating powerful and efficient thrust. But NTP systems won't be used on Earth. Instead, they'll be launched into space by chemical rockets before they're turned on. They can reduce travel times to Mars by up to 25% and limit the crew's exposure to cosmic radiation. A very interesting concept was the demonstration rocket for agile cislunar operations, DRACO, developed under the joint auspices of DARPA, NASA, Lockheed Martin, and BWX Technologies, unfortunately cancelled in May 2025. Artificial intelligence and robotics. In the coming years, AI will dramatically transform our world, and it will also play a key role on Mars. From autonomous rovers and drones that explore the area and help build and maintain Mars infrastructure, since humans should not spend too much time exposed to radiation outside the colony, to the extraction of valuable resources by an army of robots. As Elon Musk put it,
well, you need to recreate the entire base of industry of Earth.
Flying robotic systems like Astrobee are already being tested on the ISS. AI will also be essential in medical diagnostics, process optimization, and managing life support systems. Astronauts will wear wearables that continuously collect health data analyzed in real time by AI. Life support and energy systems will also rely on numerous sensors monitored by autonomous systems to quickly respond to problems. The big question: what decision will an advanced AI make if it has to choose between shutting itself down or disabling life support systems? Even today's AIs try to avoid shutdowns, as a case from May 2025 has shown. Communication systems, Marslink. Elon Musk has already announced a significant increase in Starlink satellite production and plans to build a Marslink network. Redundancy is crucial for all Mars tech, and the more Marslink satellites there are, the less prone the system is to failure. Why is it important? Reliable communication between Earth and Mars is essential for mission control and crew safety. Like current Starlink satellites, Marslink satellites will communicate via radio and laser, enabling the transfer of large data volumes. Yet, even at the speed of light, signals will take up to 22 minutes to reach Earth. NASA's Laser Communications Relay demonstration and Germany's DLR project OSIRIS, Optical Communication in Space, have already shown what's possible. A swarm of drones and robots will need to be coordinated through this network. That's why we need high-bandwidth, delay-tolerant networks for real-time operations and backup. Artificial gravity. While artificial gravity would be beneficial during the journey to Mars or on its surface, no operational system has yet been deployed in space. Significant research and engineering are still needed. However, in March 2024, Elon Musk stated that Starship will rotate on its way to Mars because even a small gravity vector is better than none. Mars offers only 1/3 of Earth's gravity, which will likely have significant mid-term effects on the health of Mars inhabitants. Though we won't know exactly how until humans are on site. They'll likely suffer from weaker bones, muscle atrophy, and cardiovascular issues. That's why we'll have to rely on alternatives like centrifuges. They can't fully solve the problem, but they may mitigate its effects. In our Mars-based video, we already showcased the German Aerospace Centre's short-term centrifuge technology, which could help counteract the effects of microgravity on the human body and reduce muscle and bone atrophy caused by weightlessness. Energy production and storage. Energy supply on Mars will be a critical issue, perhaps the most decisive one. Solar panels will suffice in the beginning, but for building industry and running AI data centers, we'll need much more. Due to its greater distance from the Sun, solar panels are less effective on Mars than on Earth. Also, frequent dust storms can dim sunlight for days or even weeks. That's why we'll need energy storage systems, e.g. advanced batteries, hydrogen fuel cells, to store solar energy for nighttime use. Long-term, we'll need compact nuclear reactors, e.g. killer power, for baseline power. A breakthrough in fusion energy would be even better, safe, clean, and plentiful. Radiation shielding. Mars has no global magnetic field. Cosmic and solar radiation hit the surface almost unimpeded. That means increased cancer risk, cell damage, and possible infertility for long-term Mars residents. Mars regolith, the planet's dusty top layer, could be used for shielding by building habitats with integrated protection chambers. But this would require several meters of material, making it resource-intensive. To avoid life entirely underground, we'll need radiation shielding systems. Active shielding, such as electromagnetic fields, has only been tested in labs so far, would require a lot of energy, and might be unstable during solar storms. Passive shielding, using water-rich materials, is more feasible. For example, drinking water could be stored in the walls of habitats made of transparent, multi-layered polymers, ideal for future glass domes. Transportation and mobility. Resources, underground water ice, ideal antenna locations, and areas of geological or biological interest will be scattered across the planet. The area around the colony in Arcadia Planeta, Elon Musk's long-favoured landing site, could be explored using pressurized rovers or flying drones. But to cover greater distances, a Hyperloop-style network has been proposed. While visionary, it would face major challenges: extreme temperature swings, dust storms, and material fatigue. Food production systems. Building a local food industry will be key. Musk wants to settle 1 million people on Mars by 2050. To provide such a population with essential nutrients, we can't rely solely on Earth. We'll need to build the necessary infrastructure on site. Key technologies: greenhouses with controlled environments for crops, lab-grown meat and protein alternatives, algae-based food production for high efficiency, manufacturing and recycling. Establishing an industrial base capable of producing tools and spare parts is critical. Otherwise, resupply missions from Earth would take months. Key systems: 3D printing for on-demand manufacturing, recycling systems for metals, plastics, and other materials. Dust mitigation. Besides extreme cold and radiation, Mars dust is another serious issue. Martian dust is extremely fine, abrasive, and electrostatically charged. It can clog machinery, reduce solar panel efficiency, and pose health risks if inhaled. Solutions: dust-repellent coatings for suits, solar panels, and rover components, electrostatic dust wipers, or cleaning systems. Sealed joints and filters in machinery to prevent dust intrusion. What's your opinion? Will we have a Mars colony in the near future, or is it just a dream?